Hello students, from the ancient time, the motion of the star, sun and the planet is a very interesting topic for all the human beings. Not only it is very interesting topic for all the human beings, this topic is a very surprising topic also for all the human beings. The people of ancient time remain surprised to look at the sky and the motion of the stars, sun and the planet. So many astronomers and ancient scientists worked on it to know the exact motion of the planets, stars and the sun. And in the ancient time, we have gave a theory, and that theory is called geocentric theory. It means the sun, planets and all the stars revolve around the earth, assuming that the earth is the center and earth is static, and all the other planets, star and sun revolves around it. But later on, the great Indian scientist, mathematician and astronaut, the Aryabhat, told us about the heliocentric theory. In this theory, Aryabhat said that it is not possible to assume Earth as the center because some of the natural phenomena like solar eclipse, lunar eclipse, occurrence of day and night is not possible if we assume the earth as the center and all the other celestial bodies revolves around it. So in his theory, he said all the other planets including the earth revolves around the sun, and this theory was called heliocentric. But that time this theory couldn't communicated with the Western scientist or philosopher. That's why it is not spread all over the world. After 500 years of Aryabhat, the great scientist Copernicus gave the same theory that is given by the Aryabhat, and that is the heliocentric, and which is universally accepted. And in the heliocentric, all the planets including the earth revolves around the sun, and sun is situated at the center. On the theory given by the Copernicus, the great astronomer Kepler'S gave the three basic laws which explains exactly the motion of the planets. These laws are called Kepler's laws of planetary motion. So in this lecture we are going to discuss about the Kepler's laws of planetary motion. The first law of Kepler is called the law of orbit. So first law is called law of orbit. In the ancient time, it has been assumed that all the planets revolve in a circular path around the sun. But Kepler told us that all the planets revolve around an elliptical orbit around the sun, and the sun is situated at one of the foci of this elliptical orbit. Now this is the sun. This is what? Sun, and all other planets revolve in the elliptical orbit around the sun. So we will write the first law of Kepler's, that is law of orbit. It states that all the planets revolves around the sun in an elliptical orbit with sun is situated at one of its two foci. Now we will discuss about the Kepler's second law of planetary motion, and the Kepler's second law of planetary motion is called law of areas. So we will write it. Second law, and the second law is called law of areas. According to Kepler's second law of planetary motion or law of area, every planet sweeps out equal area in equal interval of time. Try to understand it once again. According to Kepler's second law, the line joining the planets and the sun sweeps out equal area in equal interval of time. It means, suppose a planet moves for a time t from here to here and sweeps, this line sweeps a area A1 in t time. The same planet in same interval of time t, this planet again sweeps out this much area from the sun, and this area is also equal to this area. It means it is also A1. It means that the line joining the planets and the sun sweeps out equal area in equal interval of time. So we will write it. It states that, means Kepler's second law of planetary motion states the line joining the sun and the planet sweeps out equal area in equal interval of time. Now we will discuss Kepler's third law of planetary motion. And Kepler's third law of planetary motion is called law of time period. Law of time period. According to Kepler's third law of planetary motion, the time period for the revolution, the square of the time period of the revolution of the planet is directly proportional to the cube of the mean radius, and this mean radius is called semi-axis of the rotation. Student, as we know, the planet revolves in the elliptical orbit. It means the distance from the planet and the sun changes. So, for our convenience, we assume this elliptical orbit as the circular orbit, or for our convenience, we find out the mean radius for it, and that is called semi-axis, or that semi-axis is called radius of what? Elliptical orbit. So we will write, it states that, it means Kepler's third law of planetary motion states that the square of the time period for the revolution of the planet is directly proportional to the cube of the semi-axis, and we can say that radius or mean radius. Now student, the farthest distance between the sun and the planet is called aphelion, and the nearest distance between the planet and the sun is called perihelion. तो स्टूडेंट, आज के इस लेक्चर में इतना ही। जल्द मिलते हैं आपसे अगले लेक्चर में। तब तक के लिए खूब पढ़िए और अपने परिवार के साथ साथ अपने देश का भी नाम रोशन कीजिए। जय हिंद।